Can I get a couple of checks if everybody can hear me all right? Okay, perfect. Okay, so as Bill said, my name is Heather Dinon, and I am coming from the climate world. So my background is in meteorology and applied climatology. And so today I'm hoping to talk to you a little bit about how weather and climate can have some impacts to forestry. And so the idea behind this webinar is to for me to go through about a 20 to 30 minute talk, and then at the very end we'll have plenty of time for discussions. I think we've allotted up to 30 minutes for discussions. So as I go along, since I am not from the forestry background, please be thinking of ways that I might not mention, but ways that climate and weather might impact forests. And excuse me, and we'll go through that at the end during the discussion. I'd love to hear some feedback from you guys. Okay, so I'll go ahead and get started. And once again, this is the first that we've ever done, so bear with me as we go along here. The first thing I wanted to start off with was a question for you guys, and I know we've tested out sort of the checks and X's, but if you're not familiar with Illuminate, they are located underneath, on the left here, top left, you'll see the participants list, and underneath there on the right side, you'll see the check and the X. So I wanted to test that out first and give you guys a simple question. So try this out for me, if you will. Check if you like loblolly pines. So everybody should be checking, right? Okay, awesome. So everybody has found the check box. Excellent. So now my real question for you is, I'd like you to put a check box if you think that weather and climate are basically the same thing, but and so put a check if that's what your thoughts are. Okay, great. Well, they are different, and as I go through my talk, I'm going to explain that there is one specific big difference between the two, and I'll get to that in a minute here. Okay, first I wanted to give you a primer on the State Climate Office. For those of you not familiar with state climate offices, they're usually housed at universities or state agencies. And in North Carolina, we're actually housed at NC State University, which is a land-grant institute. And so our mission is threefold. We have a research mission, we have an extension mission, so we take that research and bring it to different communities and sectors. And then the third mission that we have is for outreach and education. And everybody knows this slide, which is our project, obviously, but what I want to emphasize is this last bullet here, which is the climate literacy aspect of our project. And I think that's really key to this project because I think there's a lot of climate awareness out there, but I think we're still struggling in terms of climate education. So I'm really excited to be part of this project and to really take advantage of that. Okay, let's see. So first I'd like to start off with what are the exact differences between weather and climate. So the real big difference is in the time scale. So weather is your shorter time scales, anywhere from a couple of days to a couple of weeks, versus climate is more of a longer term phenomena, and it's from anywhere from a couple of weeks to months to years to centuries, really. And bear with me here as I try and relate weather and climate to baseball. So weather is much like your at-bat in baseball, and climate is much like your seasonal batting average. So on any given at-bat, you could be like this guy in the image here on the left, and he might strike out for that one particular at-bat, but really what a better representation of his performance is his seasonal batting average, which is, this is on the right here, a really old figure, but in this particular season, Chipper Jones just so happen to have the highest batting average, but again, on any given at-bat, he might strike out. So the at-bats are like the weather, and the seasonal batting average are like the climate. And you can also relate this to the stock market. So on any given day, your stock might completely tank, which is analogous to the weather. And however, over the long term, you're probably going to come out with a gain over several years, and that's more like the climate. Okay. So this is what I like to call my climate umbrella, and these are some of the topics. It's not all-encompassing by any means, but these are some of the topics I'm going to try and cover today, with the exception of climate change, because we're going to save that for some later webinars. So what I want to emphasize with this figure here is that climate change is really just one topic under the umbrella that is climate. So I wanted to make that distinction. Okay, so what exactly drives our climate here in the southern United States? Well, it's arguably one of the most complex climates in the eastern U.S., and that's because of these three factors listed here. One is our latitude. The second is our complex geography. So we have vast differences in elevation across the region. And the third factor is our proximity to two large bodies of water, and that would be the Atlantic Ocean and the Gulf of Mexico. So what this all results in is high variability across the region. And this figure here sort of depicts some of those factors. So we have the elevation, the mountains, the higher elevations here. And then we also have the Gulf Stream here, which is obviously has a huge impact on our climate, and also the Gulf of Mexico here. So because of this complexity, defining a single climate of the southern United States becomes really difficult to do because of the high variability. And sort of going back to the baseball theme here, it would be like saying that every team in the American League East has the same exact record, which we know is not true. This particular season, the Yankees had the best record, which hurts me to say because I'm a Red Sox fan. But much like the climate, the baseball teams have these particular records because of many different factors, and it's the same with the climate in the southern U.S. is that it's due to not just one factor but many factors. Okay, so two of these factors in particular are what I'm going to talk about today, and one is the El Nino Southern Oscillation, or ENSO, and the second is the North Atlantic Oscillation, or NAO. And so these are two climate oscillations which are often studied, and this is sort of where climate variability comes in. And you can think of climate variability as being departures from your typical conditions for a particular state or site or area. Okay? So starting off with what is ENSO. This is a phenomena which occurs in the equatorial Pacific Ocean, and basically you get warmer than normal sea surface temperatures during the warm phase, which is called El Nino, and cooler than normal sea surface temperatures during the cool phase, which is also referred to as La Nina. And this is coupled with large-scale fluctuations in the air pressure, which is sort of the southern oscillation component. And when neither of these phases occur, it's obviously your neutral phase. So the greatest thing about El Nino is that it's really predictable, especially during cool season here in the southern U.S. And so we're talking about this phenomenon in the Pacific Ocean, but why do we care about it here in the southern U.S.? Well, it actually shifts our jet stream to this particular location on this diagram. And so low pressure systems will track along this jet stream. And what that means is that it has impacts on our precipitation patterns. So during El Nino winters, you get increased precipitation for the southern United States, but decreased precipitation for the Ohio River Valley here. On the converse, during La Nina, your jet stream will shift more northward as compared to El Nino winters. And so what that means in terms of precipitation patterns is that you get decreased precipitation in the southern United States and versus the Ohio River Valley, which gets increased precipitation during La Nina winters. Okay, so shifting gears to the NAO, or North Atlantic Oscillation, which is another climate oscillation I'd like to talk about today. And basically, what this refers to are fluctuations in these two pressure systems, and one being the low pressure, which is called the Icelandic low, named for its location near Iceland. And the second pressure system is the Bermuda or Azores high pressure, and that's also named for its location. And these two pressure systems are semi-permanent, and what they can have impacts on are our winter temperatures back here in the United States here, especially in the eastern United States. However, unlike ENSO, the prediction is really low in terms of the skill for forecasting this. So for the positive phase of NAO, what you have is a strengthening of these two pressure systems, and what that does is it increases the upper level westerly winds, and that can have impacts again on our temperatures in the eastern U.S. And so during positive NAO, you get typically above average temperatures across the eastern United States, which is shown here in this figure. And on the converse, during the negative phase, these two pressure systems decrease in strength, and so that has impacts on the upper level winds in that they are weakened. And so what that means is that a blocking high is able to set up, and what that means for our temperatures is that it basically drains the cold air down from Canada and Alaska into our region during negative NAO. And so you can see that here. And I'll show you a couple of examples of how that might impact us. And so one particular case study I'd like to show you, sometimes these two phenomena will interact with each other, and that's exactly what happened in December of 2009. So I'm going to show you how that went down. So we had a negative NAO setup, which this figure is actually showing your upper level geopotential heights. And I know that's a big scary word, but basically what that means is when you have these negative geopotential height anomalies, it translates to cold temperatures. And so that's exactly what we saw for December 18th, 2009. We saw really cold air come in from Canada because of the negative NAO. And we also have that coupled with the warmer than normal sea surface temperatures in the equatorial Pacific. So here's the El Nino, which is occurring. And we needed the El Nino because this, again, has impacts on our jet stream. And so we'll see, hopefully, more storms tracking along the jet stream. And that's exactly what happened and produced a winter storm for us. So we had all that cold air in place, and it was basically the perfect setup. A low pressure just tracked right along that jet stream and brought us some snow, particularly in western North Carolina and most of Virginia. So that's just one example of what can happen when these two climate oscillations can interact and have impacts on the weather. Okay, but how does this impact our forests? Well, these two oscillations might produce a scenario where you'll get ice, snow, and sleet damage, and that's obviously bad for the forest, and also cold damage during flowering is particularly bad impact. So if you can think of other impacts that might be produced from these different oscillations, please be thinking of those as I go through, and we'll talk about that during the discussion. Okay, next moving on to some extremes that we might experience in temperature and precipitation, and in particular, I want to go over a case study from 2010 because this is a very interesting year in terms of extremes. first starting off with, this was actually for the fall and early winter preceding 2010. So the storm I just showed you, the winter storm, actually is included in this period from October to December of 2009. And what this is ranks of precipitation on the statewide level. And so 115, if you see numbers of 115, that indicates that it's the record wettest year. So if you look across the southern United States, you're going to see a lot of above 100s, and that indicates that it was basically the top 10 in terms of wettest year for this particular period. And that was followed by this basically record cold winter. This is the period from January through March of 2010. Again, statewide ranks, but this is for temperature instead of precipitation. And what we're seeing across the southern region is that it's basically in the top 10 in terms of coldest temperatures that we've seen for this particular period. And this is largely due to the fact that the NAO was negative, and in fact it was actually the most negative it's ever been since its records started in 1950. So we had one of the coldest winters on record, followed by one of the warmest summers on record, which is shown here, and the 116s indicate that it was the record warmest for that particular state, and you'll notice a lot of 116s across the region, but really across the whole region it was in general in the top 10 in terms of warmest June, July, and August on record. So those are some of the extremes we've seen recently. Here are the overall extremes for some of the states in the southern region, and I apologize because Texas and Louisiana, a couple of the other states, are not included in these graphs, but let's first focus on the low temperatures here. And what you see is that there's a lot of negative values, so these are in Fahrenheit, and really a lot of these are going to be isolated to the higher elevation sites. For example, in North Carolina, this negative 34 here, that actually occurred at Mount Mitchell in January of 1985, and Mount Mitchell is the highest point east of the Mississippi, so a lot of these are isolated to the higher elevations, but I think it's still important to consider that these are what the lows could possibly get down to. And focusing on the high temperatures here, all of them are above 100 degrees, and so I'm just thinking in terms of impacts to forests. These two particular extremes, the colds are most likely too cold and could have impacts, if you did experience these conditions, on flowering and other things. You guys might share more of those later. And the highs are maybe, going to cause stress to your trees. So be thinking of other impacts from these particular extremes in temperature. Another extreme we experience in the southern region is the hurricanes. And I have this starred here because oftentimes hurricanes bring us extremes in precipitation. So what I have plotted here is total storm days for the state of Florida, and basically what it's showing is the frequency of tropical storms that impact Florida. But I will say this distribution is very similar for many of the other southern states. So it's showing here that the season typically peaks in late August to mid-September, and again, that's consistent across much of the southern United States. So one particular storm was Hurricane Hugo from 1989, and this storm developed right off of the west coast of Africa, and it tracked all along the Atlantic and hit about a Category 5 before making landfall in South Carolina. And so let's think of some of the impacts to forests. Here's a figure here to the right, which I borrowed from Tim Martin, so thanks, Tim, for that. And what it's showing is just a lot of damage to the trees obviously from the high wind speeds associated with hurricanes. Now, I was reading this article last week, I guess, and it was talking about how, you know, the high wind speeds can cause damage to the trees and knock a lot of the trees down, and so your fuel load is actually increased on the ground, which you would think would cause increased wildfires. However, that's not usually the case with hurricanes because you often, with the wind, get a lot of precipitation as well, and so the trees become saturated and probably are not going to burn for at least a year from what I was reading. So you actually don't get increased chances of wildfires. So there's probably other impacts to forests from hurricanes, and I'd love to hear your thoughts on this at the very end. So overall, what this means for us is that we have a really challenging climate in the southern United States, and so we have variations on various time scales. We also have variations across space as well. And in North Carolina, we like to say that we experience every type of severe weather except monsoons. So basically, you name the weather, we experience it. And there's also challenges that come with monitoring and predicting impacts. So you have different decisions that need to be made on different time scales, which is an added challenge. And we're not going to talk about this today, but climate change threatens to exacerbate all of these particular challenges that we face across our region. So in summary, I hope you've learned the difference between weather and climate. So weather is more of the shorter term impacts versus climate is more of the longer term. And I love this quote. I think it's by Mark Twain. Climate is what you expect, but weather is actually what you get. And we also talked a little bit about some drivers of climate variability across the region, and in particular the ENSO phenomena and the NAO phenomena, which are both climate oscillations. And I've also hope you've gained some of the ways that climate might impact forestry, in particular for the extremes in temperature and precipitation in hurricanes. And I do want to mention I purposely left out drought during my talk today because my boss, Ryan Boyles, and Eric Taylor, who's also involved with AIM-6, they're both going to be giving the next webinar on drought impacts to forestry. So they're going to address that as a completely separate issue at the next webinar. So just look forward to that. And I also, during this discussion, just really want to open it up to learning about how we as climatologists can help you guys manage your risks from climate. So with that, I'll leave you with a couple of helpful websites. And again, this webinar is recorded, so please feel free to come back if you haven't had a chance to jot them all down. Come back and check those out as well.